Okay, all right. So let's get going. Uh, so if you remember the last session you guys attended, we talked about the print statement or the print function. You remember that? That
Yes.
a function is basically just a machine that takes some kind of inputs and then spits something out, and the function is different depending on what's built into it. And Python, like every other programming language, has a whole bunch of these functions built into the software itself or the language itself. Print being one of them, where it accepts. Anybody remember what that's called? The it accepts strings, accepts integers, it accepts
Floats.
what was that?
The floats.
Floats. Yep. Numbers, floats,
Bowling.
booleans. Yep. And then
Booleans.
what's the what's the term for something that you can keep redefining over and over again?
Variables.
Variables. Yep. So and you'll hear, depending on how it's used, a variable is a argument, is a you'll hear those kind of being used interchangeably, but for our case, they mean the same thing. So a variable is something outside of a function, and when a variable is put into a function, it's along with other things, they're considered arguments. So, like an argument to a math equation. So, you could say, for example, 2 plus 3 equals x. The arguments, the inputs you have are 2 and 3, and then the function, the summation function on that would be take 2 and add 3 to it to get whatever x is. So, the I'm not being very particular on the verbiage yet because you have to understand the concepts before you start pinning them down to very specific nomenclature, if that makes sense. But as we go, we'll get closer and tighter on how we call stuff, and we'll start being more strict on coding practices. Because in reality, coding practices, there's no one hard set of rules for coding practices. One company you might work for might say, okay, I want you to do camel case for all your variables. And another company will say, yeah, you know what, you can use snake case. And another company will say, use whatever you want. And so a lot of this stuff is just arbitrary because outside of a handful of very strict things, programming they don't care. Like the computer can get around. Okay, he has a space here. He doesn't have a space there. That kind of stuff. So uh, that statement about what can go into a print function, strings, integers, cases of floats. Michael said booleans, all those things. That leads us actually into the next discussion, which is data types. So go ahead and make a new file. Okay, sorry. I think Casey and Michael, you guys have your stuff set up correctly. Maybe not, but I want you guys. We're all going to get on the same page, and so move all of your files into a folder called PCC that we're going over, and we're going to stay in this PCC folder. And when we make a new project and all that stuff, we'll do it all together so that you can more easily copy what I'm doing. That was my mistake on the last course, and people were getting confused, and we were taking out a lot of time to try to get that resolved. So, ignore some of these extra files in here because I've already went over stuff with like Michael and Caleb last week, and then Casey by himself the week before that. So there's gonna be some extra stuff in here that you guys don't have. But like when I say make a file, we're doing that in PCC right now. So
Okay.
Zach, I think you're the only one maybe still. Go ahead and you can, if you just take all those files that are outside of the PCC folder, you can highlight them
Mm-hmm.
and drag them and align them inside of it. That'll make your life a little bit easier, I think.
Yeah, I got my PCC folder.
Okay.
Just highlight. You said.
Yep, highlight everything outside of the PCC folder. So if we do this, so you can see, for example, you can see PCC has this down arrow, and there's like a line, and then it stops at variable.py, and then I made a new file here called DFG. You can see that's not indented like all those other programs, right?
Okay.
So if you have stuff that's outside of that indentation, you just click it and then drag it in and drop it.
Oh, okay.
Yep. So we're gonna do that just to make our lives easier. So when you guys have to copy like the terminals, you're not having to translate what I'm saying to what your environment looks like.
Okay.
All right. So everybody tracking?
Now I am, yes.
Okay. Cool. All right. Casey, you're good too, right?
Yeah.
Yep. All right. Cool. So let's make a new file. Call it data type, and I'm going to call it 6.3, and you can do 6.3 as well and put .py at the end. Now again, remember, you need to define what kind of file this is, so that's why we do .py. You know, when you do a Word document, there's that WRD or whatever, or if you do an Excel file, it's XLS, images are IMG, yada yada yada. Same thing with these files. Now, you can see here, when I created that, it's still outside of PCC, so I'm just going to drag it in, and then it alphabetizes it, and we're good to start going. Okay, so today we're going to cover data types, and I'm not going to cover all of them, because there's data types, and there's like sets and lists and dictionaries and arrays and stuff like that. These are just the like archetyped data types, if you will. So just to remind you, everything I type code-wise, you should type as well, because that's the best way to learn, is by doing it. So, data types. Okay, so there are numerous data types in programming. Each has its own purpose and function. And functions use one, some, or all data types. Okay, in VS Code, each data type is color coded. So this will make this statement here in VS Code makes your life so much easier. It really does. So you can see, for example, the comments are green colored, and no other content will be the same color, if you will. Michael, can you mute yourself? Everybody's hearing you typing. Thank you. Okay, so if we start, let's do a string. So we do strings are this color. You can see an integer is that lighter green. A float is the same color as an integer because it sees it as a number. Variables and functions are white. Now you guys' colors might vary here, but you can see that they're all different colors. So that's a easy way to see what kind of data type something is. Okay, So let's go ahead and start here. So the first thing we're going to talk about is strings. Strings in any computer programming a string is in any language out there. So a string is a string is a string. And that is basically a sequence of characters used to represent text. All right. So strings are noted by quotes, double quotes, or single quotes. So let's do this. So and the computer has to see, when you tell the computer, like when you give the computer a double quote, you're telling Python, okay, this next part is going to be a string, and you have to go through that and then tell it when you're done. So with strings, you'll see an open quote and a close quote. So you can see that here. So if we do print and we put in one double quote, it automatically fills in the end double quote. So that's opening quote, closing quote, and that is a paradigm to almost all programming stuff. So you'll see a function like the print function. You have to do that parentheses, and when you put in the first parenthesis, it automatically puts in the closing one, right? Same thing. You're telling the program, okay, this part that I want to be putting in here is the arguments or whatever that are going into the print statement. So if you guys are wondering why there's always a closing quote being created with the opening quote, or when you hit the quote one time and a second one gets generated, that's why. It's because Python, VS Code, whatever, has to know when you're done. Because if you don't, everything underneath that it sees as that string. Because the string can be anything. It can be numbers, can be symbols, can be slashes, all that kind of stuff. There's some things that break that, but for the most part, you have to tell it when you're done. So let's go back to this. All right. So the statement, the cowboy told the barkeep, "There's a snake in my boot." So you can see here, there's the opening double quote to tell Python you're done with that piece. So you have to have a closing double quote. And within that string, you can use single quotes as well. So you can see we have 3 single quotes, right? So a quote within a quote, and American English, that's a single quote tick, right? And then conjunctions, or whatever that's called, we also use single quotes. Now, if we were using British vernaculars, or English or whatever, we can do the opposite. So let's do that. So as you can see, I did it. I put in the single quote, put in the ending quote, but there's an error here. So remember, half your job as a programmer is to figure out what the print statements, the debug statements are telling you is wrong. So you can look here, print or open parenthesis was not closed. You see that at the very top of my little box there? It says parenthesis was not closed by PyLance. Can anybody guess what that might indicate on this statement? No? Okay, that's fine. So,
I got it.
well,
I wanted to
Sorry.
give them a
yeah,
chance to
Michael.
answer.
Michael already heard this question. Yeah.
I I did mine and it was fine at first, so I had to look at what you did wrong and I had to recreate your problem on my end because I did it perfectly the first time.
Okay, that's fine. Yeah. Do you see
It,
what?
it's showing it.
I'm
Yeah,
sorry.
it's showing up now. It says parenthesis was not closed. Pylance,
Yeah.
same as yours,
Why do you think it's saying that, Zach?
because it didn't start with a quotation
Well,
after the parenthesis.
there's a single quote.
Oh,
Yeah. Like I said up here, you can use single quotes, but you have to remember that when you use a single quote, when you use a single or double quote, it's going to look for the next time that single quote is used again, right? So it looks when it's closed. So the very next time it's used is right here, right? Because I didn't fix that. So it sees this part, the barkeep, or the cowboy told the barkeep as a string. It sees this theirs, and VS Code's like, what are you trying to do with this, dude? And then it sees this other single quote. There's the end of the other single quote, and there's this one hanging out all by itself. And so Python is expecting that there's all this stuff down here. So if we come over here, there's all this stuff. It's seeing that everything starting from here is another string. And so you can keep typing, you can do all that stuff, but you have to close it again. And then close that function. So the issue is a syntax issue because I didn't interpret the internal quotations correctly. So there's this a floating. The function is not closed, is what it's telling you. Is that the function is still waiting for the terminating parenthesis. Now that terminating parenthesis is right there, but because of all of these funky quotes I didn't correct, it's not registering that as the close of the function. It's registering it as another character in the string. So we can do something like make images and stuff like that, because it's still seeing it as a function, or still seeing it as a quote. So to fix that, what do you think we should do, Casey?
Well, you'd have to change it to the double, wouldn't you?
Yeah, you're right. Yep. So let's say all right. So yeah, you're right. So let's go ahead and copy that. So if we're going to keep this, we're going to keep it in the British stuff. All right, so the cowboy told the barkeep. Okay, from here, we're going to change it to that. And we would change this to that. But look at this. So how do we fix this part? How do we turn that apostrophe? How do we get that from a single quote to an apostrophe, basically? So it's a trick question. It's not meant. This statement
You have
is
to repeat it, don't you?
like that.
Yeah.
Let's see what it does. So let's save that and do Python data type 63.py. Let's run it. Okay. So let's look at that last statement there. The cowboy told the barkeep, "There's a snake in my boot." and where there should be an apostrophe s, there's not. It this is a trick question, and I just wanted to bring this up because you're going to always run into this kind of problem when you start juggling quotes within quotes. So this way is fine, perfectly fine. But you're going to run into issues, and you can't always predict what's going to go on in there. So what they did is somebody, either a programmer, thought of this issue, which it's an issue that's perpetual in English, and imagine, French, they use like 10 times more apostrophes than we do, right? Like they have them everywhere. It's an issue that they had to solve. So what we can do is I call it triple double quote technique. Okay? It sounds stupid, triple double quote. But really what that is if you know the string you're going to be using is going to have apostrophes and all that jazz, what you can do, 2, 3, 1, 2, 3. So you can use 3 double quotes. So you can see 1, 2, 3 openers, your text here, 3 closing double quotes. And what that does is 99%, maybe even 99.9% of your of the strings you'll ever make, if you use the triple double quote technique, you'll never run into issues with okay, I got to figure out how I'm going to handle this apostrophe s and this stuff. So it sounds really stupid, but it's incredibly powerful in Python. All right, so let's try that. So let's do triple. So we do 3 double quotes, give it a space, 3 more double quotes. And VS Code is going to try to fill it in and do all that stuff, just kind of force it into this pattern for now. All right. So the statement, the student quoted their teacher saying, "My old teacher told us don't not use double negatives." Okay, what the hell is this sentence? Well, it's meant to be very, very convoluted, just to prove that the triple double quote technique works amazing. All right, so this print statement, go ahead and type it in. This print statement is a quote within a quote within a quote. Okay? Or a quote within a quote of a string. So the student quoted their teacher saying, and then here's the quote, "My old teacher," so now this is the teacher talking, don't not use double negatives." So if we use this in any other string combination besides the triple quote, it would fail, because if we did the single double quotes, it would see this one right here and automatically say, okay, this is one string and the rest of this is just junk. If we use the single quotes, then it would not register. Well, if we used a single quote, it would register all this until it got to there, and then it would give a whole bunch of, I don't know what this is for this, and then another string, and that's not the answer. And so the only solution to this is the triple double quote technique. Now, if I can't think of a more convoluted sentence than this without getting into more and more and more quotes within quotes. But it works further and further down. So you can say, don't use double negatives as my professor was quoted saying. All right, so there we go. So again, any combination of this is always going to work with the triple double quotes. So you can see, what the hell are you teaching us? Like, good thing we're not learning English, because this would make McLoathing's head explode, right, Michael?
Yeah. Yeah, it
Would.
would.
Yeah. So that's the point. So the takeaway from this is, when you're using strings, if you know you're going to be using apostrophes and quotations and all that stuff within it, just go ahead and preface it with 3 quotes at the beginning, 3 quotes at the end, and you can do whatever you want, as long as you don't have 3 quote within quote within quotes that like that. So I don't expect that will happen. And by the time you get to something like that there's other techniques to handle more convoluted stuff than this. Okay?
So circling back to line 16.
Yeah.
What if okay, so inside of the where it says there's, if I want to try something here. If you remove one of those apostrophes and put it at the end of barkeep, and then go to the end of the string and get rid of that single, will that work?
Yeah. It does, except for the fact that it's seeing 2 different print statements now. So it works, but we have to put a space in there somewhere. So that'll work, yeah.
Cool.
But that's confusing as heck, honestly.
Yeah, it is.
So the other thing you could do is you could also do that, and then that might make it easier on the next programmer to read. Okay, this is 2 print statements, and Michael knew there was going to be an apostrophe here, so he used double quotes here instead. So that'll work. And really, it's just all on what the organization you work with dictates for stuff like this.
Would a
So
plus sign also work where the comma is?
yes, but no, because a plus sign in strings concatenates the 2 strings together, which concatenate is like this. So if we have con plus, let's say we have 3 words, con plus cat plus innate. So when you concatenate something, that becomes all one word. Okay? So if we had, this is a sentence, and each one of these is just that one word, right?
Yeah. It would take out all the spaces.
Well, it wouldn't take out the spaces. There are no spaces. These spaces don't exist. This right here doesn't exist. So it would see, this is a sentence.
I gotcha.
Yep. Because those spaces here are just for us to look at. The computer couldn't care less if you had any spaces outside of this. You could literally have this whole thing that packed up. And it'd be like, all right, cool. Spaces are for us.
Gotcha. Okay.
All right. So, depending on what color code system you're using in VS Code, strings are this like orangish peach color, right? Everybody kind of have the same color I do.
Yes.
Yep. It might be
I'll go
different.
with it.
Yeah. It doesn't matter. You can have different colors. It's all adjustable. Like Python doesn't see a color here. It only registers. Oh, this is a string. That's all that cares about. Okay. So the next data type is an integer. Okay. Now, anybody remember what an integer is?
I know the word. It's a math term, I think.
Yep. I think we talked about this last week too.
Is it a number?
It's a number, but it's a whole number.
Okay. Oh, that was close.
Yep. So those are all considered integers. A 0 is an integer, a positive number is an integer, negative is an integer. The benefit of an integer is that it uses less memory than floats. And you can still do math with integers, so you can do math with integers, but if you multiply a whole number by a whole number, it's going to be a whole number, right? So if we print 3 times 245, we're going to get that 740 or whatever, 735. And it's always going to be an integer. We can do subtraction, addition, 838 minus 999. So you can see negative 161, all integers. Now, my integers are like this light green color, which all numbers in my system have that same color for them. Integers, floats, all that kind of stuff have the same color. But integers are just whole numbers. And the reason why they're separated from numbers with decimals is you use integers to count up for a lot of stuff. So if you eventually you'll have a program that says do, print happy birthday 10 times. Well, that 10 times there's a counter in there and it adds 1 to that variable each time to count up to 10. And you don't need decimals. You don't need extra data points to do that. You just need, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Done. All right, cool. Okay, KC called the next one at the very beginning floats. And that is short for floating decimals, which basically means a number with a decimal. That can be like 8.1 or negative 92.765009. You can have lots and lots of numbers at the end there. You can do math on floats. So addition, subtraction, division, multiplication, exponentials, square roots, factorial, all those kinds of things you can do on floats. So we can do print 2.5 times 3. And that should give us, what, like 7.5? Yep, 7.5, right? And so this is considered a float because of that 0.5. Now, sometimes floats will start rounding weird because computers aren't perfect at doing calculations. you will eventually start running into weird, tiny discrepancies in math. So if we do this one, 8.3 times 3.3. I don't know what that number is off the top of my head. Okay, 279.9. But look at this print statement here. Look at all those zeros in a 3. That really doesn't exist. All those 0, 3, that may or may not exist, but it's not helpful to anything, right? Like, it's pointless. And so you'll start seeing, occasionally you'll see rounding errors, off by 1 errors, stuff like that kind of being introduced into programming. And you have to know how to handle that. So if I said I have multiply $8.30 times 33 people for how much we would make this today, you wouldn't tell me we made $273 and 90 cents and a billionth or a trillionth of a cent, right? Or you wouldn't tell me that. You'd say $273.90. I'd say, all right, cool. So how do you handle something like this when you start seeing these weird rounding things? So guess what? We're learning a new function. Okay, so round number of decimals. All right, so there's a function called round that takes the number and then it's comma, and then the next argument is the number of decimals you want it to round to. So let's take this guy. Well, here we'll do alright, so we're going to take 8.3 times 33, set it to numbers, and then we're going to round numbers, comma, 2. Alright, and then I'm going to wrap all of that in the print statement. So remember, functions can call numbers, variables, strings, arrays, whatever, or even other functions. So print is calling the function round, and round is taking these. So it's a function within a function here. So we run that. Look what we get. 273.9, and that's what we wanted. Unfortunately, that 0 is kind of an invisible 0, right? So let's do something a little bit better than that. Let's do print round 3.92933 comma 2. So, Casey, what do you think this print statement should say in the terminal? This guy.
9.
It should say 9.
Wait, hold on. Sorry, I'm using my laptop screen as watching you, and I'm using a larger monitor to type on.
Oh,
So
you're
look
okay.
Closely. So wait. So it'll round it. So when you put the number there, it will round up or round down. I don't know which one you're talking about.
This one here. So look at this function. Round takes a number, and then the second one is the number of decimals that it's going to try to keep.
So it'd be 2.93.
I think so. Yep. Let's try it. 2.93. Yep. So, yep. You're right. When it rounds, it just uses normal rounding. So if it's 5 or above, it'll round to the next number. If it's below, it'll round down. Yep. So that's how you keep numbers clean if it starts to get nasty and kind of silly, right? Because you're not going to have nice, perfect, crisp, 2 decimal numbers hardly anywhere once you start doing any kind of computational programming. So you got to use stuff like round and other things to handle that. So I'm going to try, when we first get started here, every time we use a new function, I'm going to have this new function. I want to say like new function time or new function or something like that. And then I will give you how that function is used, how it's called, and we'll give it an example. So you can always control click the function, or you can mouse over and it tells you what it's used for. So round, a number, comma, and digits. Again, you have to speak Pythonese to read that top part, but you can see underneath it, round a number to a given precision in decimal digits. The return value is an integer of n digits, is omitted or none. Otherwise, the return value of the same type of number and digits may be negative. So, again, you'll learn how to read that. You can always go on Google and say, how do I round in Python? How do I round a float in Python? It will tell you this exact statement. And the internet's your friend, and use it. Just don't use ChatGPT to do your homework, because you won't learn anything that way. You'll tell yourself you learned something, but the hard part, the most important part, is connecting those synapses in your brain. And so, all right. So new data, another data type here. Michael, what'd you call it? The last data type?
I called it booleans, but it's a boolean.
Boolean. No, Boolean.
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 Boolean, like the gold. Gotcha.
Yep. All right. So Booleans are either true or false values. This is super important because all of your loops and if statements and switch statements and cases and all that stuff use Booleans, uses true or false to run. Okay? And so, all right, so this statement. Now, typically, we would see print 10 greater than 1. If it was in a string, we would see literally the string 10 angle bracket 1, right? But when it's sitting here like this, that's not necessarily it looks, you're not doing any math to it, you're comparing it, right? So is 10 greater than 1? If it is, then the print should actually say true, as in that's a true statement. So you see that there? True. Print 2 less than 1. Okay, is that going to be a true or false statement?
False.
False.
Oh, you said 10 greater than 1? Sorry.
Nope.
That's
2
true.
is 2 less than 1.
False.
False. So false. So these are literally true or false comparisons. Okay. Do you guys understand? You understand what I'm doing here between these two print statements? Yep. Okay. Cool. All right. Okay, so new function type. A type takes an argument. Remember, an argument can be a string, integer, float, function, anything. So for type, it takes basically anything you want to put into it, and what it does is it tells. All right. So type tells you what you put in there is. Like, is it a string? Is it an integer? Is it a float? Is it whatever? So to do that, you type type. Let's do 8.3. Okay. Now, if I run this, is it going to do anything? What do you guys think?
Gonna say float.
Casey?
Sorry,
Zach?
I'm still trying to get caught up.
Where are you at?
I'm just trying to get everything typed up. I'm 40, or no, level line 50. I'm getting there.
Okay.
I don't have fast fingers.
Okay, you ready for me to ask that question again?
Not really.
Okay, what does this do? What will this do?
It'll tell us if that's an integer, a float, or a function, or a string, because it's type.
It will. Let's try it. Well, we didn't see anything there, right? So what we had to do is kind of what we had to do up here. We had to print that, right? Because type still ran. It processed. So you said, okay, what's the type of 8.3? And it ran it, and it finished. But it didn't give us any kind of output. So we had to tell it what to do. So print type 8.3. There you go. It'll tell you, oh, it's a float. So just remember, print is your best friend in these early days. Like, developers use print or log or console log, whatever, all the time when they're trying to figure stuff out. And so here we're using print to actually spit out what we're wanting to see inside there. So if we do, let's do print type sentence. Okay, Casey, what will that print out down here? What do you think?
String.
Yep, class. It'll say class string or str. Okay, so useful, very very useful. This type is super useful if you're not sure what kind. If you keep failing functions and you're like, well, why does this keeps crashing? You can use type to determine if that variable you're putting in there is a float, is a string, is a number, is yada 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 yada. And the last thing you can do is you can force values to go to other data. You can force one data type to go to another data type. So new function type int So int value will force a value into the data type. So if we do print int 8.3 or sorry 3.2 and we run it, it should only go down to, it should say 3, right? Because a float has no decimals. And an int has no decimals. And so when it takes a float, turns it to an int, it just rips off the decimals. It says, okay, that's what it is. Same thing if we do print int of 9.3. Now again, that's a string. We can force it to an integer and then print it. Well, we can't really do that, but we can take the string value of 9 and force it into an integer. We would have to take that to a float. So all right, so we're going to do a little bit more here. So float int, well, okay. So that works, right? Printed it out. Now let's do this. Sorry. Copy that. Go to the next line. So we're doing a function of inside a function inside a function. So print int float of 3.2. So that should take the value of the string 3.2, turn it into a floating number, and then take that floating number, convert it to an integer, and then print that value. And so it eventually should become 3 if it works right. There we go. So 3.
Mick, are you unmuted?
Yes, I am. Sorry.
Okay. So do you guys understand that function within a function within a function thing?
I understand that you want to go print int float to do the function within a function within a function. Every time I've been going to run something that we typed in the terminal, and I'm typing it the way you are, because I'm like obsessively checking back and forth between my phone and my screen, it keeps saying name error for everything. I don't know if I'm just not doing something right or...
I guess send me a screenshot of your code.
Everything that I've typed or everything I've run in the terminal?
The thing you're running in the terminal.